Hey you guys, I'm Sandra and welcome to one more Rui Raptor video. At the beginning of this year, we reviewed the Sapphire S 3D printer from Tutrees. Now, Tutrees released the Pro version, which includes some upgrades and modifications. The Sapphire Pro is also a Core XY printer with a 32-bit board. In this video, we will unbox and assemble this printer and at the end, we will compare both models. As usual, Rui will explain all the details.
Hey you guys! So, let's check what's inside the box. And the first thing we see is the assembly manual. Next are tools, memory card, PTFE tube, and heat sinks. A spool of PLA filament, lots of screws, T-nuts, and springs, the extruder and extruder stepper motor, the leveling sensor, the filament runout sensor, and the top frame, which includes the X and Y axis rails. Next, we have the bearings for the Z axis. A couple of belts, the Z end stop, the rubber feet, the print head, zip ties, spool holder, plastic tube to arrange the cables, the heat bed and the insulation for the heat bed, the bed platform, the power cord, some plastic strips, lead screw, and rods. Four 20 by 20 metal profiles, the base of the printer, and finally the bottom panel. Okay, everything is out of the box. Let's start the assembly. But first, let's inspect the electronics. All the boards and power supply are under the printer's base. The Sapphire Pro is equipped with an MKS Robin Nano board. This board has a 32-bit microcontroller on it. For the X and Y axis, we have a couple of TMC's 2208 drivers, and for the extruder and Z axis, we have a couple of 4988 drivers. For the driver cooling, we have a 40 by 40 fan pointed directly to the first driver. It also has a second fan on the side throwing the air out. The input voltage wires look like they are screwed in and tinned, like we normally see in other printers, but these ones are crimped, which is very good. The display is an MKS-based 3.5-inch color touchscreen. The power supply is a 24-volt and 15-amp model. The drivers came without the heat sinks, so that should be the first step. Make sure they don't touch any of the side pins. Next, grab the 4 metal profiles. They should be inserted in the corners of the base. To secure them, use the M5x16 screws. Locate the ends with the holes and insert the profiles matching the holes on the base. Secure them with a couple of screws. Next, grab the rods and insert them at the back of the base. Secure the rods by tightening the screw. Next is the lead screw, but before that, we need to adjust the height of the coupling. The motor shaft must be below the middle line of the coupling. Insert the lead screw and tighten the coupling screw. Now get the bed platform and turn it upside down. Insert both bearings and secure them with the M4x6 screws. Then, install the bed platform on the rods. Rotate the lead screw to lower the platform a little bit. Next, get the Z end stop and insert it on the left rod. Don't worry with the exact position just yet. We will adjust it later on. The top frame includes the X and Y axis rails. Before installing the top frame, check the rails and make sure the Y axis rails are parallel with each other. If everything is okay, install the top frame. Take the M5x10 screws and use them to secure the top frame. If the metal profiles don't align with the top frame, loosen the screws at the bottom. Then, tighten the top screws for the rods. Under the printer, you need to tighten the remaining 4 black screws, one on each corner. And then tighten all the side screws. Next, get the print head and inspect if everything is okay. We can see that hot end heater wires were also crimped with ferrules. Install the print head at the back side of the carriage and secure it with the screws that were already on the carriage. Now it's time to install the belts. Grab the belts and make sure you loop them teeth with teeth on the carriage. Start with the front left. Secure the belt with a zip tie. Then pass the belt around the top left idler. Then around the motor. Next, around the back left idler and the back right idler. Then around the top back idler, and finally secure it at the back right side of the carriage. Get the second belt and secure it at the front right side of the carriage. Pass it around the front lower idler, around the motor, around the back right and back left idlers, then around the lower back idler and secure it at the back left side of the carriage. Make sure the belts have a good tension, add a second zip tie and cut the remains of the belts. Next, grab the extruder and the small bag with the extruder parts. This version of the Sapphire includes a dual gear extruder. Before installing it, you need to place the screw, spring and washer on the side. This screw will define the tension of the gears on the filament. Between 2 or 3 turns on that screw will be enough for now. Next, put the screws and T-nuts on the extruder mount. Next, install the extruder on the back left profile close to the top frame. Take the spool holder and also place the screws and T-nuts. Install the spool holder on the same back left profile but near the base. Now get the heat bed. Although we found many wires with ferrules, the heated bed wires are not crimped. Instead, they have solder on their tips. We had to cut the solder off and crimp ferrules on these. And the insulation material needs to be glued on the bottom side of the heat bed. The top side of the aluminum plate is covered with the protection sheet that we need to peel off. This print pad has 5 holes for the leveling screws. This is because we can use a 3 leveling point setup or a 4 leveling point setup. You can choose which setup you want, and in our case, we will use a 4 leveling point setup. So we will install 4 screws, 4 springs, and 4 leveling knobs. If you want to use the provided print surface, you can glue it at this point. But if you plan on using a different print surface like a glass, for example, move on to the next step. In our case, we found that the head of the bed screws were a bit high because of the countersink holes were not deep enough. This will be a problem if we wanted to use a rigid print surface on top, so we need to fix this too. Now it's time to arrange all the wires and cables. In the package, we received this flexible tubing for the wires, but we are not big fans of this kind of wire tubing. Except for Becky, of course, she loves to play with this all day long. Instead, we use this flexible sleeve, which is much better. So, start by gathering all the wires coming from the X carriage and insert them in one sleeve. Secure the sleeve and the wires with the zip tie on top of the carriage. Do the same for the heatbed wires and secure them to the left bearing. We need to do this because the heatbed is not equipped with the strain relief. The Y and Z end stop wires can go in the side of the vertical profile and secured with one of the plastic strips. Next, insert both Y and Z end stop cables into the base. Do the same for the heatbed cables. And also for the wires coming from the carriage. Turn the printer on its side and cut the zip tie that is securing the wires from the board. One of them is the extruder motor cable. Pass that one out from the hole at the back. The Y-axis motor cable will go up with the front right vertical profile. And the X-axis motor cable will go up with the front left vertical profile. Next, connect the heatbed heater wires. Make sure the wires are secure. Then, plug in the temperature sensor connector. Next is the Y-axis end stop connector. Then the Z end stop connector. And the X-axis end stop connector. Next is the hot end heater wires. Also, make sure these are secure. Then, it's the hot end temperature sensor connector. The hot end fan is connected to the 24-volt connector, and the layer cooling fans are connected to the connector on the board with the label fan. The filament runout sensor cable is connected here. Take some zip ties and secure all the cables. Make sure you get a clean path between the cooling fan and the drivers. Once completed, take the bottom panel and close the base. You have 4 holes for the feet near the corners and a couple more for the M4x6 screws. For the feet, 2 trees used M3x6 screws, but these are too small. We replaced these with M3x8 screws. Now, turn the printer on its feet and secure the X and Y axis motor cables with a couple of plastic strips, and connect them to the motors. The filament runout sensor can be passed together with the extruder motor cable. 2 trees did not provide any support mount for the filament runout sensor, so we will need to design something for it later on. Next, get the small PTFE tube and insert it in the bottom fitting of the extruder. Take the longer PTFE tube and inspect the tips. If you find that the tip of the tube does not have a clean cut, get an X-Acto knife or a tube cutter and make a clean cut. Then insert the tube in the hot end. Make sure the tube goes all the way down to the nozzle. Move the hot end to the opposite side of the extruder and measure the tube. Cut the excess and insert it in the extruder. And the assembly is now complete. Now, plug in the power cord and turn on the printer. The first message we get is no files found. Just press cancel to continue. Now we need to adjust the Z end stop and level the bed. So go to Tool and then Preheat, select the heat bed and raise the temperature up to 50 degrees C. Move the Z up manually until the nozzle touches the print surface. Then adjust the Z end stop switch until you hear the click of the switch and then secure the end stop. The kit includes a contact leveling sensor. The sensor can be used instead of the Z end stop switch, and you just need to replace the end stop connection on the board with this one. The way this sensor works is, before homing the Z, you connect the sensor to its cable, and with the nozzle cold, you place the sensor on it and then run the Z home sequence. When done, you remove and disconnect the sensor. We will not use the sensor mainly because first, you need to edit the firmware to make the Z home position to be at the center of the bed instead of the corner, and second because you can only use it with the cold nozzle, which means that you cannot home the Z axis just before the print starts. Next, go to Tool and Leveling. Select the first point and level the bed using a 0.1 mm thick piece of paper. Move to the next point and repeat the process. Do this as many times as needed until all the points are leveled. The leveling point drawings on the screen do not match the exact axis positions. They have the y-axis inverted in the drawings. If you saw our Sapphire S video, you will remember us talking about the screws that secure the linear bearings being too long. With the Sapphire Pro, the screws for the bearings are fine, but the screws that secure the linear guides are either too long or the holes too short. we had to replace the M3x8 screws with some M3x6 screws to fix this. As for lubrication, we recommend using lithium grease for the lead screw and bearing oil for the linear bearings. The first time we raised the temperature on the nozzle, we noticed that with a set temperature of 200 degrees C, the readings almost reached 240 degrees C and then slowly dropped to the set temperature. We ran a PID calibration to minimize this, but even after the PID calibration, it still reaches almost 230 degrees C, but it will stabilize a bit faster. Now, take the memory card and insert it in the slot. Be careful when inserting the memory card because it's very easy to miss the slot and drop the card inside the printer. Then insert the filament. Use the filament option in the menu to load the filament. In the memory card, you will find some already sliced models ready to print. One of them is a 20mm cube, and we used that one for our first test. But our first test was not successful because we had lots of layer shift. Mechanically, everything looked okay, so we decided to measure the reference voltages of the X and Y axis drivers. And for the X-axis driver, we measured 1.62 volts. And for the Y-axis, we measured 1.75 volts, which is too high for these drivers. We adjusted the VREFs for both X and Y-axis to 1.10 volts and tested again. And this time, we were able to finish our test cube. We didn't pass the filament through the filament runout sensor because this sensor is not enabled in the firmware. And then we printed a BENCHY. And because we are close to Halloween, we printed this cute ghost. Prints done in normal mode worked great, but when printing in VASE mode, we noticed that sometimes the printer stalls for a second, which causes defects on the vases because of this top. This issue is related with the firmware itself, because the board stops all the axes at the same time and continues from the same spot, which suggests that the microcontroller is busy processing something at that time. Other than that, the print looks okay. With the test cube, we didn't notice anything wrong, except for the very light vertical lines in the X-axis. These lines are probably caused by some small vibration on the X-axis. We tested with a fast speed and with a slow speed, and the results were the same. The BENCHY test looks not bad at all, and the cooling seems effective. With the ghost, we can see smooth walls and overall good quality. And the differences between the Sapphire S and the Pro are the following. The Pro is a bit taller, the construction is much cleaner, including the display, which looks better and it's easier to read. On the Sapphire S, the two X and Y axis motors are located at the bottom and use a couple of rods to link the motors to the pulleys at the top. On the Sapphire Pro, the motors are located at the top and the two rods are not there anymore. The Sapphire S uses a Titan extruder while the Sapphire Pro uses a dual gear extruder instead. The Sapphire S has a USB slot at the front, which is very handy, while the Sapphire Pro has the memory card slot on the side. The Sapphire S is equipped with a large board, a couple of LV8729 drivers for the X and Y, and a couple of 4988 drivers for the Z and the extruder. The Sapphire Pro is equipped with an MKS Robin Nano board, a couple of TMCs 2208 for the X and Y, and a couple of 4988 drivers for the Z and the extruder. Both use the same print surface type, and which works too well because it's sometimes hard to remove the prints from it. The print area is a bit bigger on the Sapphire Pro, but we couldn't reach the 235 by 235 by 235 millimeters volume that is announced. Instead, we could only get 214 millimeters in X, 214 millimeters in Y, and 220 millimeters in Z. On the Sapphire S, the print head is secured to the front of the X carriage, while on the Pro, the print head is secured to the back of the X carriage. And because of this change with the print head location, they had to shorten the lead screw length to avoid the cables to hit the lead screw. Both models have a workable print resume feature, but with the Pro version, the Z-axis seems more stable and doesn't fall down like the S version when the power is turned off, even after greasing the lead screw. Last but not least, the idlers used in the Sapphire S are made of two bearings, while on the Pro, you get better and bigger idler pieces. And that's it, you guys. If you liked the video, give us a like, and if you are not a subscriber yet, please subscribe our channel and check all our cool videos. If you wish to help the channel, you can using our affiliate links in the video description or with Patreon or PayPal. Keep following us here on YouTube, Facebook, Instagram, and Twitter. We will see you guys next time. Bye!